Hello everyone. So today we'll be solving problem number 202, happy number. And one more thing, this is going to be the last problem in this playlist that we will be solving basically, right? So next we'll be solving this one, some LLD problems. So using programming language Java basically. So we'll be making use of Java and we'll be solving some LLD problems next, right? So this is going to be the last problem that we'll be solving in this particular playlist. So what the question states here. So here we are given a positive integer n. You can clearly see here we have been given a positive integer n. So we repeatedly replace n with the sum of the square of its digits. So sum of the square of the digits means here in this case 1 square plus n 9 square. So we will continue the same process, right? Next we get here. So they have clearly given the explanation as well. See here 82 we got. So 8 square 2 square we will be doing same. We will continue the process. If the process leads to 1, then it's a happy number. If it enters a loop without reaching 1, then it is not a happy number. So we return true if it is happy, and we return false if it is unhappy or not a happy number, right? So here you can clearly see first what we will do. We will go with 1 square and 9 square here on this case, right? So 1 square and 9 square will lead to 82. So then 8 square plus 2 square means 64 plus 4 will lead to 68. Then 6 square plus 8 square is nothing but 36 plus 64. This will lead to 100. So 100, 1 square plus 0 square plus 0 square, this will lead to 1. So as it led to 1, what we will do? We will return this one as true. So this led to 1, right? So that's what they have given in the question. So we repeatedly replace n with the sum of the square of its digits. If the process leads to 1, then that's a happy number. If it enters a loop without reaching 1, it's not a happy number. We return true if it is happy. In this case, this leads to 1, so we have to return true. So the output that they have shown here is true in this case, right? So I hope this is clear, right? So we return true if it's happy, otherwise false, right? So let's come to the second example here. Just give me a second here. Let's come to the second example here. N we have 2. 2 square will lead to 4. 2 square will lead to 4. 4 square will lead to 16. 16 square will lead to this one. 1 square plus 6 square nothing but 1 plus 36, that will lead to 37. So it will go on, but it will never lead to 1. So it will never lead to 1. In this case, we have to return the output false. They have clearly mentioned in the question. Only if the process leads to 1, then it's a happy number, then we have to return true, else we have to return false, right? So here in this case we have to return false. Easy, right? So I hope the question is completely clear. What we need to do is completely clear as well, right? First let's discuss the approach, then let's write the code and discuss the complexities for the code that we have written. Let's discuss the approach first. So here first thing that we need to note down here is we will be going with the Floyd cycle detection, or we also call this one as tortoise and hare algorithm, right? So basically we make use of this one. We made use of this one while we solved the problems on linked list, if you remember, right? So I have considered the same first example that they have given in the question, so that it will be easier to understand. We have already discussed this one, right? So here first what we'll do, we'll square 1 and 9. So this number and this number will take. This will be 1 square and 9 square is nothing but here in this case 1 plus 81, which will lead to 82 basically. 8 square, next what we'll do, 8 square plus 2 square, nothing but 64 plus 4, this will lead to 68. Next it will be 6 square plus 8 square, again 64 plus 36, this will lead to 100. So here next step is 1 square plus 0 square plus 0 square, which will lead to 1 basically. So as it led to 1, we have to return true in this case, right? So we have to return true in this case. So if it only leads to the true, if it only leads to 1, then only we have to return true, else we have to return false if it doesn't, right? So in this case we have squaring of the numbers repeatedly has led to 1, so we have written true in this case. We got the output true, so that's what they have given for the output, right? So they have given the boolean value true in this case. So let's we know this one, we have already discussed this one. So let's discuss the step-by-step execution. Let's discuss the step-by-step execution. Just give me a second here. Did I miss out anything here? No, right? So yeah, first what we will do, we will initialize 2 pointers. So let's consider the same example here. N equals 19. What we will do, we will initialize the 2 pointers. One is slow and another one is fast, right? Slow will be initially 19, right? Slow will be 19, fast will be get next of 19. So next of 19 is nothing but here in this case, fast will be 1 square plus 9 square, that we got here is 81. Fast is 81, slow is 19 in this case, right? So we will repeat the same process. Slow equals get next of slow, fast equals get next of fast. So fast is one step, means fast we are moving 2 steps at a time, slow we will move only 1 step at a time, right? So we will stop when fast equals 1, that means when number is happy. If slow equals fast, then cycle is detected and then it is not happy, right? That's what, this is the approach that we'll be going with. For n equals 19, what happens here, we got 81, right? So here in this case, this is 82, sorry, in this case. So next we'll carry on with same thing. This will be 82. This will lead to 68, basically 8 square plus this square, 8 square plus 2 square, this will be 68 basically. Next we will be considering slow as 68, and this case it will be 100. So here in this case 100, because let me write this one, 6 square plus 8 square here. In this case it will lead to 100, so we'll be considering 100 here. This will be 1 square plus 0 square plus 0 square, this will be 1. So as we have got 1 here, fast reaches 1, so this will be fast, right? This is fast, right side whatever we have written. So fast has reached 1, so the number is happy in this case. So that is the reason what we will do, we will return true. When we got 1, when fast reached 1, because fast reached 1, we will be returning the boolean value true. If it didn't reach 1, if the cycle was detected, suppose let's just assume that cycle was detected and it didn't reach 1, then we had to return this one, a boolean value false. In this case cycle has been detected and we have 1 in this case, right? So it will lead to the boolean value true. This will lead to the boolean value true, right? So the output that we got here is true in this case. Just keep this in mind, the output that we got here is true in this case. So now the output that we got here is true, and the output that they have mentioned for the first example is also true. So now we are completely familiar with this one approach. As we are completely familiar with the approach, we are good to write the code. Let's start writing the code. So let's start writing the code here. The first step is we'll be making use of the slow and fast pointer, right? So I'll just go with the slow equals here. In this case, slow equals, let me initialize this one to 1 n, sorry, and let me initialize the fast to so we'll be making use of the helper function get next here, right? So we'll be making use of the helper function get next here in this case. So what we will do here in this case, let's write the helper function first, and then let's make use of the same function within the main function, means is happy function, right? So here in this case, I'll just write here private int get next of let me go with the parameter num here, which is of the type integer basically. So within this function, what we'll do, we have to store the result. So I'll just consider here, let me initialize the sum to 0. So we are storing the sum. Let me initialize that one to 0 first. Then we have to process all the digits, right? So let me make use of the while loop here. While num not equal to 0, then within the while loop, what we will do, we will extract the last digit, we will separate it, and we will add to the sum, right? So here, that one we can write in this way. So I'll just consider some random variable here, the num module 10. What we are doing here, we are extracting the last digit. After extracting the last digit, we have to square it and add to the sum, right? So that's what we had seen in the approach as well. So I can just write in this way, sum equals sum and sum equals sum plus d into d, the previous one variable what we have assigned this one d to num module 10, right here in this case. So this is fine. Finally, we have to remove the last digit. For removing the last digit, we can just make use of n equals num by 10 basically, right? So this is it for the code. So the next step is we have to return the total sum of squares, right? Whenever suppose 19 was let's consider this one 19 here. So after squaring this one 1 square and 9 square, we have to return the total sum of the squares, right? So that's what. So here in this case, what I'll do, I'll just give a return sum. So this is fine. So the next step here is this one. What do we call? Int fast equals first. What we will do? Let's assign this one to the function called getNext here. So getNext is the helper function that we have already written. So this is the reason we have written the helper function getNext. So we are making use of it on the main function, and we have assigned this one to the fast pointer getNext of n. Nothing but this is the first pointer that starts with one step ahead or one move ahead, right? So next step here is we have to loop until first reaches 1. We have to loop until first reaches 1. Means if it is happy, first will reach 1, or if the cycle is detected, first will never reach 1, right? So here on this case, I can just write while loop while first not equal to 1 and slow not equal to fast. Then what we will do here in this case, within the while condition, let's move slow by 1 step, and also let's move fast by 2 steps. We will be moving slow by 1 step and we will be moving fast by 2 steps in this case. So I'll just give slow equals get next of slow here in this case, and the next step is we have to move the fast by 2 steps, right? So I can just write here get next. We have already discussed this one in the approach as well. Fast slow is get next of slow. Fast is get next of within 2 steps ahead, right? So this has to be get next of within the function get next of fast. So I hope this is clear why we have written this one get next of fast. So we are moving 2 steps ahead here. We are moving the fast by 2 steps. This is fine. So the final step here is we have to return the fast. If fast reached 1, then it's a happy number, right? So we'll just return here fast equals 1. We are comparing, right? Whether we are checking whether it has reached 1 or not. If it has, then we will get the boolean value true. If the cycle is detected and if it hasn't reached this one, then we will return false in this case. So let me do one thing here. Let me format the code once and let me hit the run button. So here line number 4, int fast equals get next of n we have here. So what mistake I have done here? That get next of int get next itself I have written. Oh, so here this has to be get next, right? So this is fine. I had misspelled here, so it wasn't working. So here you can clearly see the sample test cases are getting passed, right? So let me hit the submit button. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct on this case, right? So let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is Floyd's cycle detection algorithm, also known as tortoise and hare algorithm, right? So that overall time complexity here, it would be big O of logarithmic n, right? So why it is big O of logarithmic n and why it is not big O of n here? Because it is big O of logarithmic n for the transformation into number of steps till loop or 1, right? Till the steps that we look at 1 square plus 9 square for n equals 19, 1 square plus 9 square, then we got 82, 8 square plus 2 square. Those operations we did, right? So for transformation in it is big O of logarithmic n, means big O of log n per transformation into number of steps till loop or 1. So in practice this is basically big O of 1. Since the results repeat within the small values, we can also write here instead of logarithmic n, we can just write here big O of 1. So just give me a second here. So I'll just write here big O of 1. This is fine. So what would be the space complexity then? The space complexity would be big O of 1 as well. Why it is big O of 1 here? We are not making use of any extra data structures. We are just going with the variables slow, fast, and sum. You can clearly see here. We are just going with the slow, fast, and sum. Right? Slow, fast, and sum. So sum this one, this variable. Slow, fast, and sum. So these are the variables we are going with. So there is no extra data structures that is being used here. So the space complexity would be big of 1 in this case. So the time complexity and the space complexity for the code that we have written is big of 1, right? I hope whatever the code that we have written is completely clear as well, along with the complexities that we discussed, right? So one more thing, now we have solved around solved 70 problems, right? This is enough. Next, what we'll be doing here is we will be solving around 10 problems, 10 main problems, LLD problems, by making use of Java. We'll be considering programming language Java basically to solve the LLD problem, some important LLD problems, right, that might be asked in the interviews. So we'll be solving the same, right? For now, this is it. Thanks for watching, guys.